around the world to generate electricity, cook our food, heat our homes and power many buses. It's crucial to almost every aspect of our lives. Our project targets natural gas located within coal seams in regional Queensland. Coal seams were formed millions of years ago from decomposing plant, animal and swamp life. As the trees and plants died in areas containing ancient rivers and streams, it formed peat, which was buried and fossilised, settling in layers or seams. These layers of peat were transformed into coal due to natural increases in heat and pressure. Natural gas is a byproduct of this coal formation and is stored in one of two ways: deep underground in coal seams, where the gas is bound to the coal, or through conventional gas deposits, mainly found in sandstone layers. Before we can produce gas, we first invest in exploration phases that research where coal seams may be located and their ability to release gas. The first step is to build a general picture of the local geology of the land with a field study called a seismic review. Using small trucks that can easily access the survey area, this review can be used to gather a three-dimensional picture of the potential location of gas deposits. It's a non-invasive method of bouncing energy waves into the ground, which send data back to a receiver truck. This data can be combined with core hole drilling, where samples of the earth are taken in order to get a better picture of the exact depth of the coal, as well as its gas content and quality. Using the same process that landholders use to drill a water bore, a pilot well may be drilled if the data indicates that an area may contain good quantities of gas. By drilling a pilot well, we can access the coal seams in order to start testing gas from the coal. Located deep underground, below shallow water aquifers, the coal seam formation is made up of around 98% solid coal, which contains natural fractures or cleats that leave only 2% empty space. This space is also occupied by water. Unlike conventional gas deposits in sandstone, where the gas fills up 30% of the empty space within the formation, in coal seams, the gas is contained in the solid part of the coal. Through chemical processes over time, the gas adheres to the coal and is held in place with pressure over millions of years. There must be geological containment from the layers of the rock above and below in order to trap the gas so it can't escape. If a number of pilot wells within a region show that it is a viable production area, then we finalise the location of production wells through careful consideration of the landscape and discussions with the landholder. Many factors and constraints are taken into account during this time, including environmental, ecological and landholder concerns, before an agreement is reached on the development of wells and gathering infrastructure. Coal seams are traditionally accessed using a single vertical well. We start by drilling a surface hole through the most shallow layer of earth. As the drill head moves down, drilling fluid is pumped into the well hole. This is required to lubricate and cool the bit, remove cuttings, and most importantly, to provide pressure. The well pressure and the earth formation pressure must be at equilibrium in order to ensure that water from aquifers can't escape into the well, nor drilling fluid into aquifers. As we pass through an aquifer, we control the density of the drilling fluid to ensure the pressure remains balanced and the integrity of the well is maintained. As we drill deeper, we encounter different levels of pressure, so we need to isolate certain layers to continue to ensure total well integrity. To achieve this, a surface casing is initially inserted. Cement is then pushed through the casing using specialist plugs that allow the cement to flow out through an opening at the bottom before setting in place to provide a sealed wall of steel casing and cement sheath between the earth and the well hole. This isolates the surrounding environment, including any intersected aquifers. This process is repeated until we reach the layer above the coal seam, where the final casing is cemented in place. We then drill into the coal formation without the need for casing. Once sufficient water has been removed from the coal seam to reduce pressure, gas will begin to flow from the seam while the coal resources remain in place. Over time, the water rate will decrease as the pressure in the coal seam lowers. Various techniques have been developed to enhance the amounts of gas that are released from the coal. One option is fracture stimulation, where fracturing fluid is pumped into the well at high pressure in order to enhance naturally occurring fractures within the coal, as well as producing more. The fluid transports sand into narrow fractures, propping them open and allowing the gas to flow into the well more easily. The fluid is 98.5% water and sand, with a small amount of additives such as guar gum, borax and citric acid, which are found in everyday household products. Not all coal seams require fracture stimulation, and the most favoured position is that the coal seams flow gas efficiently without the need to add this process. Another option that minimises the environmental footprint of the production phase is to engage in deviated well production, where multiple wells stem from the one pad, in order to increase the overall production area within the coal seams. Both options are safe, highly regulated, low-impact methods of increasing productivity. With the well integrity secure, production can commence. As the water and gas reach the wellhead at the surface, they are separated. The gas, being lighter, rises to the top of the vessel, while the heavier water falls to the bottom. From the separator, the gas and water are independently pumped for separate processing via an underground network of pipes. The extracted water is treated to filter the salt content and alter the chemical balance, so it can be reused in a number of beneficial ways. The gas is transported to dehydration and compression facilities to make it completely dry before it is sent up our main gas transmission pipeline to be further processed for export on Curtis Island near Gladstone.